Well, as I recorded the last video and said topology instead of topography repeatedly, I thought it was important to record another video. I should point out that I'm recording this on a Sunday evening, so all caveats, as with the last video I was recording on the Sunday evening as well. So all caveats associated with my quality of commentary should be made in advance on this. So let's talk about the ApeSDK associated with what you'll find. So the ApeSDK is basically a toolkit, which is named accordingly, of stuff that is needed. The whole thing is written in C with the simulated ape also being written in C, Objective-C and Swift. The aim is within the next year to remove all the Objective-C and move it to Swift full hand associated with this stuff. So when you see Mac here, combination of Objective-C and Swift currently, and then this is the simulation specifically. So this will hopefully in the next year all be moved to Swift on the Mac side. And then you have the basis of the SDK is the toolkit, a scripting language called ApeScript, and the underlying simulation, which has got the tiles, which we talked about in the previous video. The land is made up of tiles, be it a flat landscape or a planetary landscape. Planetary landscape has 6 tiles. Flat landscape has 1 tile. There's a potential to make a much higher resolution version and have maybe 4x4 tiles in the flat landscape, or, that certainly is a possibility. One I probably should explore, actually. So ApeScript is used for scripting the entity's movement and pick up resources and processing resources and potentially, neural networks, all this kind of stuff can be written through ApeScript. It's maintained separately here. I think we probably should talk about the toolkit first, associated with what that contains. There's a need for audio processing, both with regards to kind of ape speak and input as well. So the audio processing, which contains an FFT and all the good stuff associated with AIFF, which is the means of communicating data in and out through audio, if not through speakers and what have you. The underlying console is basically everything that's needed for running a kind of command line console. Help information, helpline, entry in the console, quitting out of the console. This is relatively basic in, where is it? GUI, I think, perhaps. One of the other one, maybe Universe. Universe has the command. So for the toolkit, this is for everything related to, all the possible simulations that would want a console. For simulated ape specifically, ApeSim as well. There's Universe. ApeSim is the iOS version of simulated ape. So here you have an expanded command system specifically for the simulated ape or ApeSim. File handling, a lot of this stuff you would get in a more modern language for, in JavaScript you'd probably need some modules for it, but in most modern languages you get a lot of the stuff that the toolkit provides. For example, there's a JavaScript object, in-out interface for the simulation. You'd get that in most modern languages. Memory handling, maybe not so much, but there's memory handling here. There's underlying mathematics, and the vector mathematics has been pulled out because there's a lot of additional vector mathematics that's used. What else have we talked about here? Mathematics, I/O. So this is a lot of string handling, lots of different pieces fit in I/O. And graph, I think this is basically to allow for 8-bit and 32-bit color and various effects through this. So most of this is really used in other, so for example, the urban simulation uses this graphical stuff a lot more, but it's here for use for any simulation sub-projects. So I think I've covered everything here. Vector mathematics, general mathematics, I/O string handling, file handling, console, audio, and object, which is basically object and JSON. JSON in, out, and an underlying, object handler for JSON objects. So we talked a little bit about land in the previous video. This contains both the landscape generation, also the weather generation, and I think there's time components here as well. So yeah, space-time, weather, landscape, all there. Territories, this was designed for naming territories, so the apes could actually refer to the various areas in the map with kind of collective naming. So, peninsulas, ponds, rivers, springs, these kind of things. This is only partially implemented, so to be continued. And we talked a little bit about tile in the last video. So that's the notion that each component of the landscape is considered a tile. So, sorry, each square 512 landscape element is considered a tile. And it would be possible to stack these tiles, so make the two-dimensional environment 4 tiles by 4 tiles, say, but where it's really useful is in the planetary simulation, where you have 6 tiles creating a cube. So ApeScript it's divided in terms of the parser, which parses the ApeScript code, and the interpreter, which runs the ApeScript code. I think that's pretty standard. The Mac code, so there have been 3 graphical permutations of this on the Mac platform. The first was Core Graphics, then there was an OpenGL version, then there was a Metal version, and then there was a bug in the Metal version about, 18 months ago, basically, which just made me pull the Metal version and go back to Core Graphics. I could revisit the Metal version, but it was just a kind of frustrating element, because in rewriting the OpenGL version, which basically had been the main means of running it on Apple's platforms, it was problematic, basically, the movement to Metal. I had to rewrite a lot of the low-level stuff, which you can see in graph.c. But yeah, it was just painful. So back to Core Graphics for now, with the ability to switch this out to Metal sometime in the future. And this is all associated with all the ApeSDK Mac apps, aside from simulated Ape and ApeSim, the Mac and iOS versions, which have the additional, where are we, MacSim. So there's also iOS versions in there. So we talked about Toolkit. Entity is basically the simulation of the agent. Various components of it. There used to be quite a complex vascular system and diseases and things like this. A fellow by the name of Bob Mottram contributed a lot of source code to the ApeSDK 2009 through to 2012. And that contained a lot of disease simulation, this kind of stuff, which we'll probably go back to, actually, as part of this YouTube channel's remit. But also skeletons, the drives, the episodic. So, for example, when you run the simulation, here you get to see some of the episodic interactions. So if it runs for a bit of time, we'll come back to it in a minute or two. We should have some episodic stuff up there. But also the social aspects of the simulation. Here it's associated with the social graph, the notion of kind of underlying, necessarily actors, but internal representations of individuals, and obviously external representations as well, and also speaking. We talked a little bit about command. There's a lot of looping here. I rewrote a good portion of the ApeSDK to be functional, and some of that comes through the looping as well. I've moved back from a lot of the functional methodology, but certainly there was a time when the ApeSDK was very much, processor and multiprocessor agnostic, so spread out over, multiple threads and, providing an interface to allow for all the looping, because there's lots of conditions where you want to run this on all the apes at the same time, basically. Sim is it's just a place to put the stuff associated with initializing the simulation, some of the underlying components. It's a catch-all in some regard for the interface of the simulation, going up to the graphics in particular. This relates to how to move the underlying data within the simulation through to JavaScript objects. So it's just basically building up objects and at the same time kind of decomposing objects into the underlying simulation elements, basically. And then you have the GUI, which contains drawing, things like icons. What do we got in here? About dialogue, various string characteristics, particularly this notion of smart strings, which are strings that have links that are clickable, which you can see. We'll go back to that window in a minute. During the weather, all this, at a relatively high level. And then messages, which I don't think has ever really been expanded upon. This was an idea of like communication, basically, I think, between... this is an element of the simulation. Spaces, copied message, time to expire. I think, this is a means of communication, which is kind of embodied now in the control window, which I'll show in a minute. And shared is just the interface from the GUI layer to the platform-specific layer, basically, the thing that says Mac, Windows, iOS, and how to kind of communicate that and the like stuff. So if you see here, we've had an opportunity. So these are the links which enable you to move between apes. But as you can see here, let's find a... these are all very boring apes, aren't they? Well, this one's okay. So this is the series of events as they've occurred and importance. The ape maintains some, notion of these events and time frames, and that's how it's represented here. So that's the events and social graph component of the underlying agent simulation. So I hope I've given some overview of this thing, and we'll talk more in future videos about how to simulate pandemics. And there's a very basic pandemic simulation that's already here. Where are we? Healthy carrier. But I'll look at how we can simulate more interesting pandemics going forward. And just as a means of long-term simulation, as a means of looking at pandemic data in real time to see what it actually means in an environment where we can start interrogating the various components. So please subscribe if you're interested in more information. Please like. Please leave comments as well, because I'm going to use the comments on these videos as a means of directing the videos going forward. So hopefully this is made up for the topography dilemma in the first video. But I wanted to give some introduction while things are fresh with regards to this channel.